Okay, welcome to Module 1, Identifying Points, Lines, and Planes. In geometry, we have three unidentified terms, which are point, line, and plane. A point is the basic unit of geometry. It has no size, is infinitely small, and has only location, and it is named with a capital letter. So an example would be if you had point A. A line is going to be a straight arrangement of points. There are going to be infinitely many points on a line. A line has infinite length but no thickness and extends forever in two directions. And you're going to name a line by 2 points on the line or a lowercase cursive letter. So if I take my example up here and I add another point and I take the straight line through those 2 points, I could name this by AB, 2 letters, and you have to put an arrow above it in order to indicate that it is a line. Now the second way to do it is if you have a lowercase cursive letter right next to it. So this could also be line L. A plane has length and width, but it has no thickness. It is going to be a flat surface, so think of a two-dimensional surface like a piece of paper or a desktop or a tabletop. It's going to be a flat surface that extends forever. And a plane is going to be named by either 3 points or capital cursive letter. So I'm going to put my plane here. So if I have 3 points, A, B, and C, you draw a rectangle around this. This acts as a plane. Now, capital cursive letter I could put in the upper right-hand corner, and that could also be labeled as plane M. And labeling in geometry is pretty important. 2 other terms in geometry that are important are collinear and coplanar. The word within collinear, which is line, and it means on the same line. So collinear is on the same line. So if I have my figure here, collinear means that I have my figure. I have A, B, and C. A, B, and C are all on the same line. If you're non-collinear or not on the same line, that means you're going to be A. B is going to be up here, off of the line, and then you have C here. Coplanar, just like collinear, means on the same plane, so on the same flat two-dimensional surface. So if you have points, if you have points on a tabletop, for example, A, B, C, and D, those would be coplanar points. So let's say B fell off the table. You could technically say that this is a non-coplanar point. So C, D, and B fell off. So B would be a non-coplanar point. Defined terms of geometry can be described using known words such as point or line. A line segment or segment, you can also say, consists of 2 points called the endpoints of the segment, and all the points between them that are collinear with the 2 points. So an example would be is if I have my 2 points, my 2 endpoints, A and B, and unlike a line, they are endpoints. They do not extend off forever. Your name, just like a line, is going to use 2 letters, but you're going to have a segment on top of it. So this could be segment AB. You could also put BA if you really wanted to. It does not matter. Array consists of the endpoint A and all points that lie on the same side of A as B. So, for example, I'm going to put my example in the open space just because it's going to be a little bit easier. So I could have my endpoint A, and then I call this my directional point B. Or, again, endpoint A, directional point B. The thing I tell my students is always, you have your endpoint, and then you have your directional point when you name these. So for the name, Your endpoint in this case is going to be A. Your directional point in this case is going to be B, and then you always put an arrow to the right, signifying that it is a ray. And both these rays have this exact same name, even though they're going in opposite directions. Next thing is an opposite ray. And an opposite ray share the same endpoint and go in opposite directions along the same line. So that means they have to share the endpoint. So I'm going to do my example here. If I draw a line and I have A, B, and C, there's my example. And I could have, it's the same exact way as a ray. So one would be, your starting point would be B, or your ending point. Your ending point or your starting point would be B. Directional is A. And that's your first ray. Now the one that is opposite of this is you have, again, your end point or your starting point is B, and then you go along the directional point of C. And those are your names for your opposite rays. So I have guided examples of points, lines, segments, and rays in this figure. Some examples of points that you can see here: point E, point J, point F. Those are the points, and I separate them by columns. Example of a line: again, you take 2 points and you draw the line on top of it. EJ is one, EF is another, but also remember the lowercase cursive letter that you can also have to name a line. Examples of segments: you have EJ, JE. The only difference again with the segment is that you have an arrow for a line and a segment for the line segment. And examples of rays: remember you have your beginning point or end point, and then your directional point. And all the arrows, if you notice, go to the right. So at my starting point E, directional point J, or end point. Take a few seconds to kind of see if you can do the directed example and find some other points, lines, segments, and rays. So I have some other points. Here are some other lines. Here are some other segments and other rays. So there's many different answers that can be given. Which rays are the same, which rays are different, I'm going to leave that to you. Another thing you have to do in geometry is you have to do sketched examples. So sketching an intersection of lines and planes. So I have in this, the model example is sketch a plane and a line in that plane. So I have a parallelogram that basically one of the other things you're going to have to do is sketching a lot of figures in geometry. So I have sketching intersection of lines and planes. The first one, the model example, sketch a plane and a line in that plane. As you can see, I've got my plane is drawn. It's a parallelogram that's kind of that indicates the plane. You have the labeling here, which is indicating that it is a plane, and you have your line that is actually on the plane, and it's labeled as well. For the guided, you have sketch a plane and a line that intersects the plane at one point. What I tell people, think of a piece of paper and think of a pencil that goes right through the piece of paper. Now, when you draw this, again, we have the same thing, and I've put my labeling over here. It really doesn't matter as long as it's in one of the corners of the plane. You have your line L is labeled, and the dotted line is actually indicating going through the plane. And dotted lines are basically things that you have to kind of imagine. So this dotted line or this pencil is going through the plane, and you have to imagine where that dotted line is. For the directed, you have sketch a plane and a line that does not intersect the plane. Well, you have to think of the line's going to be off of the plane. Now, one thing I didn't go over, but is we went over a little bit in the previous part of the notes. You can also label your line with 2 letters. It does not matter. It's up to you. So we have sketching intersection of lines. It says sketch 2 planes that intersect in a line. Think of 2 planes as you have note cards. They come together, they intersect in a line. So here's one. I have a rectangle. The second one's a little harder because you have to draw a plane going through, which, remember, if you can't see it, you draw a dotted line, and that acts as the imaginary part. And then we have our line. And make sure you label your planes. So I can label this Q, I can label this R. It doesn't really matter. It's up to you. And here's our intersection of line M as well. And this concludes Module 1.